Hello everyone. So in this lecture we are going to discuss the topic that is threaded binary tree. So what is threaded binary tree? So threaded binary tree is a similar as of binary tree, but there is one difference, that is in the storing the null pointers. Right now I'll explain you. Suppose we have a binary tree something like this. Right, now let us see the link representation. So in a link representation, if I show you, so this is my A, and then I'm having this B, and then C, then this one is D, and here we have E. Right, now in this, as you can see that this leaf nodes, right, so leaf node are not having any child, right, so here the left and right pointer there will store null, right, because null represent there is no more for the child, right. Similar in a C also we have this null, right. So this is like the node contain a null pointer, right, either in the left or right. Suppose like if this have any right child, so this null is replaced with the pointer, and here this would be null, right. So these, like this space is wasted, right, because we are storing the null pointers, right, though it is representing us that there is no more child, right. So but one case that if we replace this null pointer with some useful piece of information, right, that can be done, right. So here in this, what we are going to do, that suppose we store it in order predecessor or in order successor, so it makes us traversing very much convenient, right, because in this scenario if you traverse, right, so I traverse like from A to B, B to D, then again I need to backtrack, right. Now this is only 2 levels, right, but suppose we have a very large tree, right, and if we go to the from root to the leaf node, right, and there are like 10 to 15 intermediate nodes available here there, right, so I need to again go backward, right, backtracking is there, right. So here in this threaded binary tree, what we do, that we replace it with in order successor and predecessor, right. So we are storing that, right. So these are the special pointers, and these special pointers are called as threads, and those binary tree which contains threads are known as a threaded binary tree, right. So there are two way of threading, right, there are two way of threaded binary tree. One is a one way threading, and second is two way threading, right. So in a one way threading, we have only like a single thread tree, right. Let me explain you that, like one way threading, that means you have single threaded tree, right. Now the single threaded tree means what, that in that also we have two parts, right. One is left threaded and the another one is right threaded. You might get the idea already. So in this, what we are doing, that in a right threaded we replace the right field with the in order successor, right, and in a left threaded we replace the left pointer, left field with the in order predecessor, right. So suppose like in the previous example, same like we have this A, B, C, D and E over here, right? So this A, this here we have this B, then we have this D, then we have this E, right? And here we have C, right? So these are null over here, right? So first what we'll do, we'll find the in order of that particular tree, right? So what is in order? You know LVR, right? So that's a left, visit and right. So if you find the in order, right? So in order, so you can go for D, B, E, A and C. That's your in order, right? Now in this in order, if you can see that successor of this D is what? B. B is a successor, right? So we are going to replace this right pointer with in order successor. That's called my thread, right? Then similar way, the successor of E is A. So this null pointer is replaced with this. So this is my thread. Thread means what? It stores the address. This position stores the address of its successor, that's a A. And this address stores its address of a successor, that's a B, right? Here C is not having any successor, so we are not replacing this null, right? So here what we did, we replaced the right field with in order successor. So this combination leads to right threaded tree, right? Similar way, if we replace this with in order predecessor, that will replace in left, that leads to left threaded tree, right? So here you can see that if we do that, right? So I'll make change here only. So this this we have this D, here we have null, right? Here we have this E, both is null, right? Right, this is null, right? So what is the predecessor? So predecessor is here, the predecessor D is not having any predecessor, right? So this null will remain same. Now E is having predecessor, that's a B, right? So we replace this null with the value of address of B, right? So that is left thread, right? Similar way, C is having predecessor, that's A, right? So this null would be replaced with the address of A, right? So this result in left threaded tree, right? And so I hope you understood this, right? So it makes like traversing more convenient, right? Now what about two-way threading? So you already might get an idea that two-way threading, and that we replace both the fields, right? So suppose we have this right? So let me represent this like in a linked structure, right? So if we find in order, so that's a D, B, E, A, C, right? So what we'll do, that this D's successor is B, right? So this thread will be there. E's successor is A, so this thread will be there. C is not having any successor, right? Then D is not having any predecessor, so that will be null. C is not having successor, so that will be null, right? Then E's predecessor is B, so this thread will be there, right? And C's predecessor is A, so again this thread will be there, right? So this location is replaced. So here we are replacing both left and right, right? So that is called two-way threading, or it can also be called multi-threaded tree. That's a single threaded tree, and this one is multi-threaded tree, right? So here we have both the left thread and the right thread. Here if we represent in this is a link structure, right? This one is linked structure, right? So in a simple tree, if I want to show, then simply I can have the dotted line to the thread, and if it is going from the right side, that's a right thread, from the left side, that's a left thread, right? So we'll simply have this B, then this left thread, then this would be the right thread, and this would be the left thread, right? So this is multi-threading, right? So I hope you understood this, what is threaded binary tree. In that there are two types, single threaded and multi-threaded. Single threaded, that means it is again having two things, right? Left threaded and right threaded. And multi-threaded, that's in that you replace both the pointers, right? So that's it, right? So the advantage, we can say that advantage of having a threaded binary tree, that's it would be easy for traversing, right? Traversing, so linear traversal, that it eliminates the use of stacks, right? Which in turns like consume a lot of memory space, right? And even the computing time, right? So yeah, that's it, right, in this lecture. So for traversing, it makes easier, right? So I hope you understood threaded binary tree, right? Stay tuned for more concepts of data structure. Thank you very much.